Welcome to a term project in CE 197, Pavement Design and Evaluation. A simplified analysis of North Avenue Road, lying between SM Mall North EDSA and Quezon Memorial Circle. Our goal here is evaluation of the pavement surface roughness. We have selected a route, now we will set up a method and then analyze the pavement. How to conduct an evaluation in the absence of standard tools for pavement engineering. This will be the focus of this study using limited instruments. Journey from Philcoa to SM will be utilized for recording vertical accelerations. Data will be recorded by accelerometer. This is not a standard method and is subject to various limitations. Ultimate goal here is to learn how roughness estimation works. Set up an efficient smartphone accelerometer. Record the vertical accelerations of one-way journey. Try to estimate the ride quality or surface roughness of the pavement. Ride in a UV express van. Common observations are: spring or dampers have higher shock absorption effects. This results in smaller magnitude of vertical acceleration, resulting in smoother ride. Here is a rough visualization of vehicle movements and vertical force reactions. Jeepneys have less wheel and spring damping effects. This is also chosen as the main utility for ride quality assessment. Consider vertical forces and displacement along seating lines. And then, choose positions which are around middle or right above back wheel. We will use the concept of force equals mass times acceleration and force equals spring constant times displacement. Smartphones have similar mechanisms with a moving mass, springs, capacitive plates to measure acceleration. Various applications or tools are available. Option 1, use accelerometer, navigator and screen recorder. And then, capture the graph. Option 2, export acceleration data as CSV file and then open it in MS Excel. Start of observations was in November 2023 and ended in January 2024 with the given recording timeline. First we will estimate the mass that will be designated to a wheel. Approximately 3,500 kilograms of total empty mass, which can be distributed four-wheel parts, can be partitioned to empty mass of 800 to 900 kilograms, with full capacity passengers up to 200 to 300 kilograms. Total gravitational force is 10.8 to 11 kilonewtons. Net force equals mass times accelerometer reading, which is also equal to normal force minus gravitational force. Use a spreadsheet to compute corresponding values. Then equate it to spring coefficients times vertical deflections. Assume that spring contraction caused by net force is directly usable. Upward deflections are caused by restoration of spring or oscillation, which is, though not readily usable, can be approximated to net force effect. In the absence of detectors directly attached to the springs and several unknown parameters, accelerometer data serves only as arbitrary set of numbers, recalling our focus on procedure rather than accuracy of result. Typical values of spring coefficients can be used instead of calibration. Adopt a spring constant of around 50 kilonewtons over meter. Damping mechanisms are unknown and assume for old Jeeps, damping is negligible. Tire, acting as spring, will have coefficients typically around 50 to 300 kilonewtons over meter. Physics Toolbox Sensor is a good application that supports CSV exporting of acceleration data. Generally the ride is of constant speed around 15 meters per second through an uninterrupted route from Quezon Memorial Circle exit to Mindanao Avenue intersection. Here are a few sample outputs of this experiment. The roughness index is in meters over kilometers for a ride with speed of 50 kilometers per hour. An alternative method is using acceleration as the second derivative of displacement and integrating the acceleration data twice using numerical methods like trapezoidal or Simpson's rule. The limitations are: lack of standard tools in this experiment. Errors in the process of recording data. Too many unknown parameters and assumed values. Here are some benefits. The process is simple, economical, and experimental. It helps in learning the basic concepts, helps to set up templates for computation, and some ideas can be used for similar studies further.